This screencast demonstrates the integration of the Hydrology Common-Service into the SUDPLAN Scenario Management System. It is divided into 5 parts, whereas the first 2 are of preparatory nature and the latter 3 depict the main use case. Part 1 demonstrates how we can add new measurement stations to the SMS. Part 2 then shows how we can add measurement data to the SMS and the newly created station. After that, we start with creating a new so-called model for our area of interest, which will be then calibrated in the next step. Finally, we will see how to run simulations of our area of interest. In order to prepare our hydrological simulation, we first of all need to create a new monitor station in the area of our interest. This is necessary to add local measurement data, which we will use later on to increase the accuracy of the simulation. If we open the hydrology section of the catalog, we can see the monitor station node. It does not contain a station which is suitable for our needs. Thus, we create a new monitor station by choosing the new object from the contextual menu of the monitor station. Now the SMS displays the so-called editor view, where we can add metadata of the monitor station, such as a name, a context, and the measured variables. A very important property of a station, however, is its location. Thus, we somehow must be able to choose it, and the most natural way would be to simply point to the location on the map. So we select the mapping component and navigate to the area of our interest. For this screencast, we create a station in Saarbrücken. After we navigated to the correct place, we select the new point mode from the toolbar of the mapping component and click on the very point where the station shall be situated. A new point is created and the point symbol will be displayed on the map. Now we can switch back to the editor view and choose the new point from the geometry chooser. After specifying a name, the context, and the variable measured by this monitor station, we can now save the monitor station by clicking on the floppy disk in the Editor tab's toolbar. After the save operation is finished successfully, the new station appears in the catalog and we can have a look at it in the description view and even on the map. Now the station is ready for time series association. After we made sure that we have a monitor station that suits our needs, we can import time series that have been measured there. This can be done using the import wizard, which is reachable from the main SMS toolbar in the upper left corner. We click on the import series button and the wizard pops up. It asks us for a file which contains the time series data. To choose one, we can browse the file system using the Choose button. After we have located and selected the file, we click Next and are prompted to specify the converter that is able to convert the data within the file into the internal format of the SMS. So we have to be aware of the format of the file content. For our demo file, we use the CSV converter number 3. And click Next. The wizard now reads the data from the file and actually does the conversion. When it is finished, we can go on by clicking the Next button. The fourth step lets us enter a name and a description for the newly created time series. Moreover, we may also tick the forecast checkbox if the imported time series has already been projected to the future by some external service. Besides the name of the time series, the station to associate it with is most important. This list offers every available station of the SMS. We choose the one we previously created and can then go to the last step. In the last step, the newly created time series is added to the internal SMS storage. After a final click to the Finish button, the time series is ready for usage and also located in the right spot. Now we have done our preparatory work and may start to dive into the hydrological part of the SMS. In order to do a simulation for our region of interest, we need a so-called local model. This could best be described as a workspace that will later on be adapted to our local conditions so that the results are as accurate as possible. Local models are catchment or basin based, thus they are workspaces with a basin as a reference point. Thus we first have to retrieve the basin in our region of interest. This can be done by doing a right click on the map. The pop-up menu offers us the option to show the local basin, which we want right now. The SMS fetches the basin this very point lies in. It is our basin or catchment area of interest, so we want to do simulations. Thus we choose the Create Local Model action from the area's contextual menu. A wizard comes up and we only have to enter some metadata before we click Finish. The SMS now tells the common service to create a new local model for that area, and as soon as this call has finished, the local model appears in the upstream model section of the hydrology catalog and we are ready for the next step. After we created the local model for our area of interest, we will calibrate it. Calibration is the process that adapts the generic local model to our local conditions. Calibration is done using locally measured time series. The more time series we can use for the calibration, the more exact the results of a simulation will be. The time series are assigned to the areas, primarily our area of interest and secondary to upstream areas, the areas that directly or transitively drain into our area of interest. Please note that currently only one time series per basin is supported. If we want to assign a time series to a basin, we first of all request the basin. And then, the basin's pop-up menu offers us the Assign Time Series operation, which we choose. Another wizard pops up and requests which calibration we want to use to make the assignment. Furthermore, we have to choose our local measurement time series for the area. With Finish, we close the wizard. To further enhance the results, we can also add time series for the upstream areas. For this screencast we will omit this, since it is completely analogous to the assignment to the area of interest. Basically, the local model is now set up for the calibration. Thus, we started via the pop-up menu action of our area of interest. The calibration wizard comes up and we again need to choose which calibration we want to do. Finally, we can enter additional metadata and start the process by hitting the Finish button. The calibration may take some time, usually more than a day, so we just leave it alone until the SMS notifies us about the end of the process. As soon as this happens, we can download the calibration results, and when this is finished, we can have a look at the calibration results. The results view shows us our local time series and the model results after the calibration side by side, so that we can decide whether we want to go on with this data or if we want to redo the calibration using more time series assigned to the upstream areas. However, we have to be aware of the fact that the once calibrated local model is immutable and cannot be recalibrated. If we were unsatisfied with the current results, we would have to create a new local model to be able to do a new calibration. We finally are satisfied with the calibration results and are ready to do the final step, the simulation for our area of interest. To do so, we simply choose the Do Simulation action from the contextual menu of our area of interest and follow the upcoming result steps. The wizard requests first of all a calibrated model to be chosen. We naturally choose the one we did previously and continue with the next step. The next step offers us a list of currently available scenarios. A short description is shown that briefly informs us about the selected scenario's properties. If we want to see more information on the selected scenario, we simply click on the description and our default browser will display the online information on scenarios located on the official SUDPLAN website. For this screencast, we choose the ECAM5 scenario and hit Next. In this step, we may choose a time range for the simulation, but we will leave it as it is because the default, the longest possible time span, is selected. The final step, as always, asks for a name and an optional description before we can ultimately start the simulation by finishing the wizard. The simulation may also take a while, but usually far less time than the calibration. After half an hour, there probably is a result already. The SMS informs us about the finished run and we can download and show the results. A hydrological simulation always puts out 6 different variables in form of time series. All of them are viewable in the results view at once. If you open up the Simulations node below our local model, we also find our simulation again. Below the results object, all the created time series are available too. So these 5 steps sum up the main hydrological use case implemented in the SUDPLAN Scenario Management System. Thank you for your attention and goodbye.